Welcome back to the GCSE Maths Pro YouTube channel. Today's video is the second part of Pythagoras and Trigonometry, where we're going to be specifically looking at the start of basic trigonometry and how to calculate sides. So this is the section 2 SOH CAH TOA. This is for both tiers. So the next two pages are going to be good ones for you to screenshot and keep for your revision. Here we have the three formulas. So we've got sin, cos and tan. You will have noticed those buttons on your calculator. We've obviously got right angle triangle here with the correct labels, and we've got this acronym SOH CAH TOA. So trigonometry, or in this case basic trigonometry, where we're looking specifically at right angle triangles, okay? So basic trigonometry, SOH CAH TOA, only works for right angle triangles, and in difference to Pythagoras' theorem, which is where we have two sides and we want to find the third one, this one we could be given two sides but we want to find an angle, or we're given a side and an angle and we want to find another side. So we're still working with three pieces of information, but now we're throwing in some angles. That's kind of the difference between Pythagoras and trig. Now, we're going to label the triangle similar to Pythagoras, but in this case we've got different letters. So we've got O, A and H, which as you can see here represents opposite, adjacent and hypotenuse. Obviously opposite, that's kind of self-explanatory. Adjacent means next to, right? So fancy way of saying next to. So you can see in this case the A is next to, it's the side that's next to the angle. And the hypotenuse is the same as always, it's the diagonal side, the longest side, okay? So we've got opposite, adjacent, hypotenuse. Now the hypotenuse will always be the longest side, but the opposite and the adjacent depend on which angle are we referring to. So for example here, that's why I've labelled this one. This little symbol here means theta. They might use x, they might use theta, but it basically just means I don't know what this angle is. Obviously, therefore, that side is the opposite side, isn't it? Literally opposite the angle. And as I said, this one is adjacent. It's the one next to it that's not the hypotenuse. So for example, if my angle was actually here, the opposite and the adjacent would swap round, wouldn't they? That would be the opposite, and then that would be the adjacent. So it really depends on which angle they're referring to, okay, as to which is opposite, which is adjacent. Now, this seems like a lot of formulas to memorize, which is why we have the acronym SOH CAH TOA. It's a little bit easier to remember. So SOH, you can see, is going to be sin, which means opposite over hypotenuse. We've got CAH, which is for cos, which is adjacent over hypotenuse, and TOA, which is tan, which means opposite over adjacent. So SOH CAH TOA can be an easy way to remember all three of these formulas, instead of having to literally sit down and memorize them. Okay, there are two ways to work out what calculation we'll need, because it depends. Obviously, once you've chosen sin, cos or tan, you then need to figure out actually what am I putting in my calculator. You might prefer to start with these formulas and rearrange them. That's fine. I personally prefer to use the formula triangles because it's still based on SOH CAH TOA. All you have to remember is the middle letter is the one that goes at the top of the formula triangle. The other two letters, it doesn't really matter. Okay, so you can see here I've got SOH, CAH and TOA. So feel free to screenshot this one as well if you want to use the formula triangle method. That's the one I'm going to be showing you today. So let's actually get into it and see how it works. So here we have work out the length of x. We've got a right angle triangle. Now they might tell you to use trigonometry, they might just literally say work out the length of x, and you have to figure out, oh, I need trigonometry for this. Again, try and be clear on what the difference between Pythagoras and trigonometry is. Pythagoras is all sides, okay? So you've got two sides, one missing. There's nothing to do with angles. Trigonometry is when we start to bring in an angle. That's how I kind of distinguish it. So it's kind of similar. The first step is going to be to label the sides, but in this case, I'm actually going to only label two sides. Because when I use SOH CAH TOA, which you can see I've got up here, it's always based on just a combination of two sides. If I label all three sides, it's not going to help me choose which of sin or cos or tan I'm going to need. So I'm going to label the two sides that are relevant. In this case, obviously the 5 centimeters is relevant because that's helpful information, isn't it? What side is that? Well, as you can see, it's literally opposite the angle, isn't it? So it's the opposite. And then the other side that's relevant is the x, because that's the one I want to find out. And that one is the diagonal, the hypotenuse, isn't it? This one down the bottom is technically the adjacent. However, I don't know what it is and I don't want to find out what it is. So it's not relevant, it's not helpful to me. So I'm going to ignore that one. Once I've labelled two sides that are actually relevant, that helps me narrow it down. Which of SOH, CAH and TOA has both O and H? Well, it's going to be SOH, isn't it? Which represents sin. Okay, on your calculator, it represents the sin button. I don't know if you can see my mouse here. We've got sin, cos or tan. Each question you're going to choose most of the time just one of those. Okay, so sin, cos, or tan, in this case we need to use sin. So step 1, label the triangle with the 2 relevant sides. Step 2, figure out is it sin, cos, or tan. This is where I then bring in my formula triangle because, yeah, okay, I know I need to use sin, but what do I actually put in my calculator? So I just scribble a little triangle. You won't get any marks for this, it's just for your own help. So as I said, the middle letter always goes at the top, so the O. We cross out the letter we're looking for, isn't it? So we're looking for the hypotenuse. So if I cross that out, do you see how I'm left with? The hypotenuse is equal to the opposite, and then S represents a sin, okay? Now, sin, cos, and tan, the buttons on your calculator, always go with the angle, okay? Always with the angle. Obviously, the hypotenuse and the opposite are the sides. So that's my formula. Now I can substitute in what I know. The hypotenuse in this case is x, isn't it? The opposite is 5. And sin of the angle is going to be sin 48. So this is what I need to put into my calculator. So grab your calculator, fraction, 5 divided by, and then you just press the sin button. It will open up a bracket. So you put 48, close the bracket, and then equals. Most of the time you're going to get loads of decimals. So in this case, we're just going to round to 1 decimal place. That will be 6.7. And because the hypotenuse is a side, I'm obviously going to put centimetres. That's my answer. Okay, we went through it quite slowly, but that's it. Label the 2 sides, figure out is it SOH, CAH or TOA, use my formula triangle to actually work out what equation to use, and then just put it in the calculator. Okay, that's it. So let's try another one. Okay, so work out the length of x again. We've got obviously our SOH, CAH, TOA here, which is the bit that you want to try and memorise if you can to help you. Label the 2 sides that are useful, that are relevant. 7.8, clearly relevant, right? It's a number. That one in this case is the hypotenuse, isn't it? It's the diagonal, it's the longest side. The other one that's relevant is x, because that's the one I want to find out. Now in relation to my angle, that one is the adjacent, isn't it? It's next to the angle. It's not opposite, it's next to it. So that is the adjacent. So I've got A and H. So the vertical side is actually not relevant, is it? We know it's the opposite, but I don't have it and I don't want to know what it is. So it's not relevant, I'm not going to label it. So I'm going to go through SOH, CAH, TOA, which one has A and H? Well, that's obviously CAH, isn't it? So in this case, I need to use cos on my calculator. So I'm going to draw a rough sketch of that formula triangle, obviously use CAH. A goes at the top, the middle letter always goes at the top. Which one are we looking for? We're looking for the adjacent this time. So cross out the adjacent. Now in a formula triangle, the 2 bottom ones are actually timesed, aren't they? They're multiplied. So that means here, the adjacent equals cos, again, sin, cos, and tan always go with the angle, okay? So cos of the angle times by the hypotenuse. Now I can substitute in my actual numbers. So in this case, the adjacent is x. Cos of the angle, so that's 32 degrees, times by the hypotenuse, which is 7.8. And that is what I'm going to put in my calculator. So literally, cos obviously opens up the bracket, so make sure you close the bracket afterwards, times 7.8. Again, 1 decimal place, that's 6.6 centimetres because it is a side. And that's it. It's just the same process over and over again, okay? We just have to make sure we choose the right sin, cos, or tan to start with. So let's have a go at this one. Label the 2 sides that are relevant to me. Obviously 12.1 is relevant. In relation to my angle, that one is adjacent, isn't it? It's next to. So adjacent, and then the x is relevant because I want to find out what it is. That one is opposite my angle, isn't it? So the opposite. Now, obviously the diagonal is a hypotenuse, but again, it's just not relevant, is it? We don't need to know what it is. We don't have it already. We don't need to think about it. So SOH, CAH, TOA, which one has O and A? Obviously that's going to be TOA, which means we need to use the tan button. So I quickly draw a sketch of my formula triangle. Which one am I looking for? I'm looking for the opposite. Cross that one out. So my formula is the opposite is equal to tan, again, of the angle, times by the adjacent. And now if I put in my numbers, x is equal to tan of 27 degrees times by 12.1. And that's what goes in my calculator. So tan of 27, again, close the bracket, times 12.1 is 6.2 this time. For some reason they're all 6 point something, that's just a fluke. So again, centimetres because it is a side. That's our answer. That's the basis of basic trigonometry, so trigonometry based on right-angled triangles and SOH CAH TOA. Now we've got a couple of questions to finish with that are a little bit trickier. So again, with what we did with Pythagoras, we went through Pythagoras and then we did a few slightly more complex questions. We're still going to be doing trigonometry as normal though, okay? So just applying it in maybe a slightly more complicated situation. So let's see, work out the length of x to 1 decimal place, so here. Now, often when we have two triangles stuck together like this, it kind of insinuates that we don't have enough information about the actual triangle we want. Obviously we want x over here, so that's the right-hand triangle. We don't actually have enough information currently to work it out, do we? Because we need two pieces of information to then find out the third. We've only got 65 degrees, we haven't got anything else. So, to find out a side, I need another side, don't I? So I'm going to look at my left-hand triangle, and I can use that. I've got two pieces of information here, so I could use that to find out another side. The side that's helpful is this one in the middle, isn't it? Because they share it. Both triangles share that side. So I'm kind of just doing trigonometry twice, basically. So we're going to look at the left-hand triangle first. I want to find out this side in the middle here. So label the two sides that are relevant. Obviously, 15.6 is relevant because it's a number. That is the adjacent, isn't it? It's next to the angle. Then the one I want is the opposite, isn't it? Because it's literally opposite the angle. Okay, so SOH CAH TOA, I need to use tan. Quick sketch of my formula triangle. I'm wanting to find the opposite, so cross that out. I need to do opposite is tan of the angle times by adjacent. So in this case, tan of 41 times by 15.6. That's what's going to go in my calculator. So tan of 41, close bracket, times 15.6. Okay, now because this is kind of halfway through our working out, it's not the final answer, I don't really want to round it yet. I might write down a few decimal places, but I'm going to use my answer button, you know, this A and S button at the bottom, because that will copy all of these digits. So I'm going to write down a few of them, 13.56 maybe. Dot, dot, dot. Okay, so that does go on. I'm going to use my actual answer button in my calculator, okay, so don't round it too soon. So I'm writing 13.56 here, but really I'm going to use the whole answer in my calculator button. Okay, so now that I've got an extra piece of information about my right-hand triangle, I can go on to step 2 and actually work out the question. So let's use a different colour. The two sides that are relevant to this triangle are obviously 13.56, that's still the opposite, isn't it, just for this triangle now. And then the x, which is the one I want to find out, which in this case is the hypotenuse. So you go through SOH CAH TOA, okay, I'm going to need SOH, I'm going to need sin on my calculator. So in my formula triangle I have SOH. I'm looking for the hypotenuse. So that's the one I cross out. So my formula is hypotenuse is equal to the opposite over sin of the angle. In this case we have the hypotenuse as x, so x equals the opposite, which I'm writing, again I'm writing 13.56, but I'm going to use my answer button in the calculator, okay, I'm not going to round it like that, over sin of the angle, which is 65 degrees. So on my calculator you can see I still have my previous answer, the 13.56 with all of the decimals. I'm just going to put a fraction like that. Then you see how I press answer button, that will copy all of my decimals so I don't round it too soon, because you might do the whole process correctly, but if you've rounded it to 13.6 for example, you might get a slightly different decimal at the end and they might mark you wrong for it, even though all of your working is technically correct. So make use of that answer button, get really familiar with it. And then sin of the angle to close the brackets. There we go. In this case, because that is my final answer, I can round it. So it says to 1 decimal place, that would actually be 15.0, wouldn't it? Some people find this quite hard to round because, yeah, you'd round up the 9, but they want 1 decimal place. I'm going to write it over here. So you can't just write 15, you have to put 0.0, even though it seems a bit pointless because they're asking for 1 decimal place. So even if the decimal place is 0, you still need to put it. So my answer is 15. Okay, so we basically just had to do it twice. That was all it was. Same thing, but we did it twice. This is our last question. As we saw with Pythagoras as well, they might not even use right-angled triangles initially. In this case, we've got a trapezium. What you can do is draw in lines on any of these shapes to create right-angled triangles where it would be helpful for you. So work out the value of x to 1 decimal place. You can see x is this one at the bottom. What I would do first, to create a right-angled triangle in the first place, is draw a line straight across here pretty much, because that is a right-angled triangle, isn't it? Okay, so you can add in lines wherever would be helpful, obviously. Make sure that you know that technically it would be a right angle triangle. Okay, now we've got this triangle, but you're looking at it going, well, I've got 77 degrees, but I kind of need more information, don't I? Two things. One, if I want to find out what x is, if I've drawn a line here, this bottom part is technically a rectangle, isn't it? In which case, that means that the base of my triangle is also x, isn't it? They would be the same length. So all I need to do is use my triangle to find out the base, and then that is the same thing as x down here at the base of the trapezium. But also I still need another side, don't I? I need two pieces of information to find out the third. That's where the 12 and the 17 come in. I could work out the height of this triangle. Now, a lot of people, as I said in the Pythagoras one, kind of look at it and guess. Sometimes it looks like it's half, sometimes it looks like it's a third or a quarter or whatever. Don't ever guess, okay? Nothing's ever drawn accurately, nothing's ever drawn to scale. They should give you enough information to work it out mathematically. So you shouldn't ever really be guessing, basically. In this case, I know that if one vertical side is 17 and the other vertical side is 12, this blue bit I've just highlighted here should be the difference, shouldn't it? So 17 minus 12 is going to give me 5 centimetres. Okay, so I've worked it out in that sense. Look at both of the vertical sides and it's obviously the difference between them. Right, so now I've got my triangle. We're just going to go through and use trigonometry. So label the two sides that are relevant. Obviously 5 is relevant. That one is the adjacent. It's next to the angle, isn't it? But not the hypotenuse. And then the x is opposite the angle. So obviously that's the opposite. So then I go SOH CAH TOA, which one has both O and A, obviously TOA. Get my formula triangle so I know actually what to put in my calculator. Now I'm looking for the opposite, so that's the one I'm going to cross out. So my formula is the opposite is equal to tan, again, of the angle. The angle always goes with the sin or the cos or the tan, times by the adjacent. So in this case, x equals tan of 77 times 5. And that is literally what I'm going to put in my calculator. So tan of 77 times 5. Okay, now because that is the final answer, isn't it? It's x. We can round it straight away. So set to one decimal place, so 21.7. There we go. That's it. Okay, so you might need to create right angle triangles if you don't have any. They've given you an angle, so you kind of know it's hinting towards possibly using trigonometry. The only other thing to really quickly mention at the end is if you're getting all the wrong answers, you're not getting the same numbers as I am, even though you're typing in the same thing, check at the top of your calculator screen. You see mine has a little D here. If yours has an R, it's in the wrong settings. It probably won't be, but just in case you're getting really odd numbers, that means it's in radians, it's just different to degrees. So if you don't have that, you need to go to Shift, Mode Setup, and you see how yours might be different numbers, but you see how mine says number 3 is degrees, basically, number 4 is radians. If yours has the little r, just swap it to degrees, okay? So make sure you've got the D at the top there, otherwise you will get all different answers. Okay, so that is everything on basic trigonometry when we're using it to find missing sides. Check out the part 2 of this, which is using the same trigonometry, but we're now going to use it to find the angles. It's very, very similar, just obviously slightly different at the end. So thanks for watching this video. Hopefully you found it helpful. Leave down below any questions or comments you might have and make sure to subscribe.